In the last class, when we started process, we discussed what is the process, how the process is created, when the process is created, that we have discussed. Then we went to this particular place where a new process is created. That means you submit a program for execution. The program is converted to a process. The execution state of the program is called process. Say process is created. Now, in this way, you may submit more than one program for execution. Well, you have only one CPU in your machine. You have only one CPU in your machine. So naturally, the question is, at a time, one of the process will be in the running state. The remaining processes will be either in the ready state or in the waiting state. Because running state is the CPU state. Running state is the CPU state. So if you have one CPU, then at a time only one process can be in the running state. The remaining processes either will be in the ready state or will be in the waiting state. So that's why in the last class we discussed one question, that if you have n number of CPUs in your machine, that how many maximum number of process can be in the running state. You people told that maximum number of process can be in the running state is n. Whereas any number of processes can be in the ready state or any number. তোমরা একটু মিউট করে দেবে? Any number of processes can be in the ready state, any number of processes can be in the waiting state, but maximum n number of processes can be in the CPU or in the running state, because there are maximum n CPUs in your system. So if you have 2 CPU or if you have 4 CPU machine, so maximum 2 or 4 number of processes can be in the running state. The remaining processes will be either in the ready state or waiting state. Now the question comes that why do we still, if it is a dual core or if it is a 4-core processor, then why do we say that my system is a multi-programming environment? Or I can submit 6, 7, 8 program at a time for execution. The idea is, depending on the number of CPU you have in your system, that many number of processes will be in the running state. The remaining processes are either in the ready state or waiting state. And that change of state, the change of state takes place so frequently that as a human eye, we cannot think whether it is in the running state or waiting state or ready state. So that change of state of the processes happens so frequently that as a human eye cannot detect whether it is in the running state or it is in the waiting state. And that leads to the concept of multi-programming environment, that we can give 6, 7, 10 program and all are getting executed. But mind it, all are not getting executed simultaneously. It is our feelings. It is our feelings with which we feel that all my processes are running concurrently. But actually all the processes are not getting the CPU cycle at the same time. They are getting in a time shared basis. And here the concept comes PCB, process control block. How this process control block helps. So let us assume that you have only one CPU. So that means you have only one CPU, one ALU, accumulator. one AC accumulator, one program counter, one set of CPU register. So this is a single set, right? Because you have one CPU in your system. Now you have a ready queue. You have a ready queue. In the ready queue, this is ready queue. The processes, all the incoming processes are kept in the ready queue. All the incoming processes are kept in the ready queue. So a process from the head of the ready queue will be taken and will be put in the CPU. So a process will be taken from the head of the ready queue and will be put in the CPU for execution. So obviously, the temporary result will be stored in PCAC accumulator. The next executable instruction of that particular process, P1, PC will contain the address of the next executable instructions. The other variables and temporary values will be stored in the CPU register. Right. So process P1 is in the running state. Now, after some times, process P1 may be asking for some IO devices, or P1 may be interrupted by some higher priority processes. So either P1 will be shifted from running state to waiting state, or P1 will be shifted from running state to ready state, depending on the thing that is happening. Either it may be interrupted by some higher priority process, or P1 may ask for some input output device. So for that, it will be shifted to waiting state. So the moment it will go for waiting state, listen very carefully. All the up-to-date information of this, like the accumulated value, the PC value, the CPU registers value, will be saved in the PCB of P1 process. All these up-to-date values will be saved in the PCB of P1 process, because PCB is a data structure, just like it is our personal diary. It keeps up-to-date information. So PCB P1 will keep the up-to-date information of these things. The next process P2 will come into the picture. P2 will come and will occupy the same places: CPU, AC, PC, etc., etc. Because you have only one set of this thing: CPU, accumulator, program counter, registers. So the informations of the next process P2 will be copied to this box. Maybe after some times, the P2 completes its execution, so it will be terminated. And again, P1 may come to the picture to execute. So the information of P1 will be copied from PCB of P1 to these same places. Bolo, do you understand this situation?
Yes, sir.
Yes, sir.
Any confusion with PCB? Any confusion with PCB? What is the use of PCB? Bolo, any doubt, any confusion with PCB? What is the purpose of PCB? Why PCB is used? किसी का भी कोई confusion है तो बोलो, मैं I can repeat it once again. But this is a very fundamental thing. इस जगह क्लियर हो गया तो ऑपरेटिंग सिस्टम का मेजर पार्ट क्लियर हो जाएगा. ठीक है?
Sir, what happens when a process is interrupted by a equal priority process? Will PCB
normally equal priority process में interrupt नहीं होता. If you can go for, there is a scheduling algorithm, it's called round robin scheduling. Okay, that I will discuss in subsequent classes. Round robin scheduling. In round robin scheduling, all the processes are treated as an equal priority, except some system processes. All the remaining user processes are treated as equal priority process. In that case, every process will get a fixed amount of time for execution. उसके अंदर अगर if it is executed, it will be terminated. If it is not executed, it will be sent back to the tail of the ready queue. So every process will be given an equal amount of time. Within that time period, if it is executed, fine. If it is not executed, it will be sent to the ready queue to keep it in the hold. वो हो सकता है. All the processes are having the same priority. So basically, interrupt means a process which was running in the CPU will be stopped with some reason, maybe higher priority process or maybe some scheduling algorithm. It is interrupted, मतलब stop हो गया, and it is sent back to ready queue. So before completion its execution, it is sent back to the tail of the ready queue. That is called interrupt. बोलो अर्णव कुछ बोलबे?
No sir.
ठीक है? Yeah. See, whatever I discussed, it is in a separate, I mean, in another slide, it is showing like this way. So this is my, this thick line is the execution state, and this line is called the idle state. Well, the process is idle. Either it is in the waiting state or it is in the ready state. So if you see the pattern of a process, it is in contiguous mode or is a kind of execution state, then idle state, execution state, then idle state, execution state, then idle state. I mean, in this way it goes on. So let us assume there are two processes in the system. There are two processes. It's a very small diagram. I mean, very conceptually very small. There are two processes, P0 and P1. There are two processes in the system. And you have only one CPU. You have only one CPU and there are two processes running in your system. So how the operating system is managing these two processes for executing in a single CPU? Just see. First, P0 is executed. So at the beginning, P0 was executed. While P0 was executed, after some times, P0 may be interrupted. Maybe in whatever reason, we are not bothering about the reason. So the up-to-date information of P0, the up-to-date state information, rather we should say, up-to-date state information of P0, like the value of ALU accumulator, the value of program counter, the values of CPU registers, the input-output files, other memory management informations, all will be saved. All will be saved in PCB0. That means PCB0 is the PCB value or the data structure or the personal file for process PU0. PCB0 is the personal file in our language, or it is a data structure created specifically for process 0. So the up-to-date state information of process P0 will be saved in the PCB0. And it is being idle. Maybe it goes for waiting state, or maybe it has been interrupted by some higher priority process or whatever. So it goes to idle state. On the other hand, P0 was idle. After some times, as the CPU is free now, because P0 come out from the CPU, so CPU is free now. the PCB information of process P1 will be reloaded to the CPU and other registers and will start executing. So you see P1 start executing. P0 start executing. After some times, P0 may be interrupted, or maybe it may look for some kind of IO devices. So the up-to-date state information of P1 will be saved in PCB1. Up-to-date state information of process P1 will be saved in the data structure or the personal file of PCB1. Okay? And then process P1 goes for idle state. On the other hand, after some times, P0 again come out to be executed. So it will be reloaded. So one process is executing, the other process is idle. One process is executing, the other process is idle. So it is a contiguous fashion. And the process which goes for executing, the PCB value will be reloaded in the CPU and the CPU registers. So whatever I discussed, the same thing is pictorially represented here. ঠিক আছে? বলো। If you have any questions, please let me know.
Sir, here
বলো।
at some time the CPU is totally idle, like between save state into PCB1 and reload state from PCB0. It is completely idle, like there is no executing process. So like why does this, like,
So
if there are a lot of interrupts?
That means you are wasting your CPU cycle. That means both the process P0 and P1 are doing some kind of IO devices and CPU is idle. हो सकता है. That means the amount of CPU cycle you have in your machine that may not be utilized properly, the tasks that you have given. That means you can give more tasks to the system, but you are not giving. You are not giving that much of task. That's why the CPU is arcing.
So this is kind of a bottleneck.
Yes, this kind of bottleneck. That means you are underutilization. It's called underutilization. You have the potential to study a lot, but due to the hostile culture of NIT Durgapur, you people are not studying. You are unutilizing your merit. You have the potential. You have a very good score in a joint entrance exam. You have a very good score in joint entrance exam. That's why you got computer science here. Correct. But due to the hostile culture and this friend culture, you are wasting your whole time. You know that you will be getting a job. उसके ज़्यादा तुम्हारा कोई ज़रूरत भी नहीं है सोचने का. That's the thing. So you are underutilizing your potential. You have a lot of potential to do, but you are not doing. Most of the time you are wasting with your friends. That's the thing. The same thing here happens. The computer that you purchase, the CPU power that you purchase, it has a lot of potential, but you are giving a very small amount of work to it for executing. So, but your system is on, so obviously the CPU is running, and the CPU is running, but you are not giving that much of task. बुझले और ना? ये करम समझ में आया?
हाँ, yes sir.
So the same thing here. You people have a lot of potential. You got here in computer science as all India based exam deke mila. You have a lot of potential, but you people are wasting your time. Instead of doing some good work, you are wasting your time with a lot of other unsung activities. Okay, so What are the content of the PCB? Process state. That is the data structure. That is the content of process control block. Process state information. Process number, which is unique in nature, just like your registration number or roll number. Program counter value. Mind it, program counter is a registered. You people told me. Program counter is a register which keep the address of the next executable instruction. So program counter. So content of the program counter. Similarly, the values of register. Memory, how the memory is being used by this particular process. List of input output files which are used for this particular program, particular process. So all these state informations are contained in the PCB. In this data structure, there are some information which are fixed throughout the lifetime, just like our registration number and roll number. The process number is fixed. The remaining fields are getting changed during the execution. Program counter value will be changed, registers value will be changed, memory limit may be changed, maybe list of input output of the files will be changed. Maybe, I'm not sure. Sometimes it may change, sometimes it may not change, depending on the requirement. But process number will be always fixed throughout the lifetime of the process. Now, this change of state from running state, ready state to running state, from running state to waiting state, or from running state to interrupt state, this change of process is called context switch. Changing the context of a process from one state to another state. Changing the state of a process from one state to another state. Am I clear? This is called context switching. Now, tell me the reason of context switching. What is the reason, or what are the reason for context switching? Follow.
So IO event.
Good, very good answer.
Priority of processes.
Priority of the processes.
Interrupts of a higher priority process.
So if a process is interrupted, if a process or a higher priority process come in the system, then the low priority process will be interrupted. Okay, so interrupt is one of the reason for context switching. Request for IO device is one of the reason for context switching. What is else? What else?
In a queue from ready to running. In a queue from ready to running. I mean, the running state is terminated now.
Yes. So running, if a running process is terminated. If a running process is terminated. So there are three reasons.
Sir, a new process being created and enqueued in the ready queue. A new process.
That is there, but the only the if your CPU is free, then only you can switch. So what are the reason for CPU getting free? One is the running process is terminated. This is one reason. The running process request for IO. Running process is getting interrupted. These are the mainly three reasons for which context switching takes place. ठीक है?
Yes, sir.
ठीक है?
Yes, sir.
Okay. Now, just very specifically, you tell me what are the steps should be taken during context switching, or what are the steps operating system should do during context switching? বলো, based on this
Sir,
discussion.
updation of the PCB.
কে বলছো? সব কিছু বলো।
Sir, updating the PCB of the running state.
Good, running process. Very good. Very good. So, updating the state information of the running process, which is getting interrupted or going for waiting state. Next.
Sir, loading the CPU register with the information from the upcoming process.
Good. So, loading the state information of the upcoming processes from its PCB. So, not only the CPU register, but of course, ACPC, all those other information. So, PCB information will be loaded. Okay? Very good. So, if you interact in the class, I don't think you should study in the exam, in the hostel or in the home. I don't think, for this, at least for my part, you don't need to study. There was a very famous term I heard in one of the lectures. Maybe it is in a lower class. The term is zero luggage. Luggage spelling ta thik likhlam kina, zero luggage. That means in my class, you don't need to take anything in the luggage. You don't need to memorize anything. So zero luggage class. Okay, good. Okay, this thing I have already discussed. Again, I'm very briefly I'm telling you. Job queue, process scheduling queues, set of all processes in the system. That means it's kind of new state in our diagram. New state, all the incoming processes. Job queue. Then you have ready queue, set of all processes residing in the main memory and ready and waiting to execute. That means this is my ready state. So one is this one, this is ready state. So set of all processes residing in the main memory and ready and waiting to be executed. Device queue, set of processes waiting for an IO devices. Device queues, mind it, here it is queue, here it is queue, here it is follow. What is the reason behind it, Abdul?
Different input output devices.
So you can have different number of input output device. You can have printer, you can have monitor, you can have keyboard, you can have mouse. So one queue for this, one queue for this, one queue for this, one queue for this. So that many number of IO device you have, that many number of queues will be there. Okay. And the process migrate among these various queue, that is process migrate among these queues. Clear?
Yes, sir.
See. This is my first one, is a ready queue. So I think you have already implemented queue in your data structure class, data structure lab.
Yes.
Using
Yes, sir.
using linked list. Using linked list.
Yes, sir. Linked list.
Good.
Yes.
So, ready queue. What is the content of the ready queue? The content of the ready queue is the set of all PCBs waiting in the ready queue. So queue में रहेगा क्या? What will be the content in the queue? In your data structure lab, you created a queue. That queue is a collection of some nodes, and each node contains some values. Maybe you have kept the information of 100 students. So each student has a name, roll number, CGPA, address, mobile number, email address. So this is the data, and that node has a pointer which points to the next node. So the next node is again a data part and a link part. The data part contains the information of the next student, that is again name, roll number, email ID, mobile number, etc., etc., etc. This node has a pointer, the link that points to the next node, which is again containing the address of the information of the third student. In the same way, this ready queue is a queue of all PCBs waiting in the ready state. So as I told in the beginning, that PCB is a data structure. PCB is a data structure or a memory unit which can keep some information. So the idea is, this is my PCB part of a process. This is a link part that points to another node. This has PCB again, the link part. PCB again link part. So obviously, what will be the last link?
Null.
Null. Very good. So it will be the null node. So obviously it will have a head. It will have a tail. Head and tail. Head of the queue, tail of the queue. Process will be taken from the head of the queue. The process will be taken from the head of the queue, one at a time. Similarly, all the same thing applicable for all the other queues, maybe the IO devices queues, whatever. So ready queue and all for all the other queues, IO devices queues, ready queue and various IO devices queues, because you may have various number of IO devices, printer, keyboard, monitor, mouse. So various IO devices queues. देखो ठीक আছে? Any confusion? Now slowly we will be moving towards process scheduling. This is my ready queue. Going back to the first slide. This is my ready queue. So newly created process will come to the queue and will be waiting to get the CPU. So all the newly incoming processes will be kept in the ready queue, and one at a time will be taken to the running state. So a new process is created that is coming to the ready queue. Ready queue is a queue which is maintaining first in, first out, first in, first out. So the processes are stored in like this, P1, P2, P3, P4, like this way. Processes will be taken from the head of the queue. Of course, we are maintaining queue, so it will be taken from the head of the queue. It is taken from the head of the queue and is sent to the CPU for execution. From the head of the queue, It is taken and send it to the CPU for execution. It goes to the CPU for execution. So process P1 is in the execution mode or execution state. There can be several cases for process P1 during its execution. During the execution of P1 in the execution state, process P1 may ask for a IO request. That means, as I have given in the example in the last classes, that in the code of P1, it is looking for a scanf function. And I mean, it is going to execute a scanf operation. So you need to give an input from the keyboard. Unless the user give an input from the keyboard, it will not be executed further. So this is called IO request. It requests for some input-output device. So to execute the scanf operation, it needs an input-output device. So P1 will go to IO request and will be queued up because it is looking for a scanf. It is going to execute the scanf operation. For scanf operation, it needs an input from the keyboard. And obviously, in the keyboard, there is a queue. In the keyboard, there is a queue. So maybe there are several processes like this may ask for keyboard. So all will be queued up in this queue. Once this queue of this IO operation is completed, once this IO operation is completed, again it will go to the tail of the queue. This is my head of the queue. Sorry, head of the queue. This tail of the queue. So this process will go after the IO operation. It will go to the tail of the queue to get further CPU cycle. To get further CPU cycle. Okay. The other operation can be, other situation can be, during the execution of P1, if it is a round robin scheduling, we will be discussing in detail about the round robin scheduling. So don't worry about that. We will solve mathematical problem with round robin scheduling. So in round robin scheduling, each process has given equal priority and a small amount of time to all the processes. That is called time slice. So P1 will come to the CPU and will be waiting for a time slice, delta t amount of time. After the expiry of delta t, it will be again sent to the tail of the ready queue, such that the other waiting process, other process in the ready queue will come and will get the delta t amount of time. That is called time slice expired. So once the delta t amount, this time slice expired of the round robin scheduling, this process will be taken from the CPU or from the execution state and will be sent to the tail of the queue. And obviously the next process will be taken from the head of the queue and will send to the CPU for execution. This is the second case. Third case. CPU during execution, P1 may create a child process. We will discuss how child process is created. It may create a child process. Even we will show in the lab also how the child process gets executed from a parent process. So during execution, P1 creates a child process. How to create a child process? Using a system call, we will discuss in more detail, This is called fork. Fork is a system call with which a child process is created of the parent process. So once P1 creates a child process, child will get execute and P1 will be waiting till the completion of the execution of the child process. So child process will be taken the charge of the CPU. So child process will be sent to the tail of the queue. Once the child process gets executed, then only the parent process will again get the chance. Other issues. P1 may be interrupted by some interruption, maybe some higher priority process. So P1 gets interrupted. So it is waiting. Wait for an interrupt, and once it happens, it will be sent to again to the tail of the queue. So P1 is interrupted and sent back to the tail of the queue. This is the representation of process scheduling. বলো তোমাদের এবার কোশ্চেন আমায়।
Sir, can you repeat why a child process was created?
Why? Of course, there are some computing requirement where instead of, I mean, a same process এটা মুছছি, হ্যাঁ। Assume there are two matrix. There are two matrix. You have written a program to multiply these two matrix. You have written a C program to multiply A, B. You can keep the entire program in sequential manner. The other approach can be multiplication of one row and another column. You can create one child process. So this row and this column will be done one child. This row and this column will be done another child. This row and this column will be done by another child. In this way, you have created a number of child and each child is responsible for doing a fraction of task. So
basically child processes are sub process of the larger process, like sub
exactly. You are very right. So child processes are the part of the main parent process, and for your computation efficiency, you are creating those things.
Okay, sir. Okay.
Sir, so child process will be in the ready queue. Will go to the ready queue.
Child process will go to the ready queue for execution. Once the child process is getting completed, then only again the parent process will get chance.
Sir, but the fork function develops a same code, and then how it can be a part of that code? Whenever we call a fork function, sir, then it create a copy of that same code.
No, it will not create a copy.
Okay.
It will not create a copy. It will use that code, but its execution will be in a separate flow or in a separate
likewise in critical section,
like as a critical section.
Okay.
Mane, for example, you just assume that in my operating system class, I used to take a lot of example from the hostel, but you people have not stayed many days in a hostel. So maybe, for example, in a hostel, you want to celebrate Saraswati Puja or maybe Teachers' Day or whatever. or some kind of hall night. Have you heard the term hall night? No, I think. Have you heard the term hall night?
No, sir.
Yes, sir.
Anyway, so in NIT hostels, I mean in everywhere it happens. In NIT hostel, student used to celebrate one day in a year for the hall night. Maybe this you people are staying suppose in hall 1. So in one day, in maybe one weekend of the whole after the semester exam or so, one day you created arranged a hall night. This is a small program, maybe with the warden, maybe with some seniors, the entire hostel boarders. So you have created some kind of dinner with some functions, some cultural events and all. So for that, you have a lot of tasks to do. So what you did, you divided the task in some context. Maybe some people is responsible for the mess, what menu will be there, how it will be prepared, how it will be booked and all. Some people who are a little bit cultural in the context of doing some kind of program, maybe music, maybe drama kind of. So they are responsible for that. Some people are fond of arranging some decoration and all. So you have given the responsibility to you created a team who is responsible for decoration. So out of this 400 students staying in the hall 1, you have created a small group, and each group is responsible for doing one task. So though the bigger task is to arrange this hall night, the bigger task is the hall night. From that hall night, you have created a small task, and each task is responsible for a small group of people. So, and this group of people can communicate with each other. ऐसा नहीं है कि they are working separately. They have some kind of communication. They can exchange their message. They can send their up-to-date information कि हम लोग यहाँ है भाई गनाचित जा रहा हूँ, चलो हम लोगों के साथ जाओगे? Yeah, we are going for city center for booking these things. If you want, you can go with me. Just like this thing. Or what is the status? कब तक तुम लोगों का काम खत्म हो जाएगा? So this type of thing you people have. So under the bigger banner of arranging hall night, you have created a small group, and each group is responsible for doing a small set of tasks. In the same thing, a main process. Under the main process, you have created a number of child process. This child process can communicate with each other. And the child process takes whatever the resource the main process have, this child process can take the resource. Maybe the files, maybe the intermediate values, the results that they can take. So that's the thing.
Sir, what will be the PCB of child process?
So PCB, for each child process, there will be a PCB again.
Okay. With different process
child
ID?
processes and threads are the same.
Yes. Process ID will be there, definitely.
Okay.
बोलो खितिस क्या बोल रहा है?
Sir, I am asking child processes and threads are the same then?
No. Creating a child process and creating thread are entirely different. Okay, we will be discussing those things. Abhi context अलग हो जाएगा.
So that means the PCB of the parent process will be having the sub PCBs for each child process. Is it like that?
Not exactly. Child process will have separate PCB, but child process can take information from the parent process. Because as you are creating a separate process, child process means you are creating a separate process. Child process means you are creating a separate process. Maybe through code, but you are creating a separate process. So obviously that process will have a separate PCB. And that's why I'm not going as Khitis asked. There was an issue. Why should you go for creating a child process or better to go for a thread?
But you told it is possible for communication in between the child process.
That you can do. but the PCB will be, but for each child process there will be some PCB. Even if it is not a siblings of the processes, any process can communicate with any other process. That is called inter-process communication. It is not the parent-child or child-child. Okay.
Okay, sir.
So, is this part clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now, we'll be slowly moving to the scheduler part. There are mainly two types of scheduler. One is the long-term scheduler, another is the short-term scheduler. Select which process should be brought into the ready queue. Is a long-term scheduler. And short-term scheduler, select which process should be executed next and allocates the CPU. So this is two different aspects. A newly process is created and is sent to the ready queue. A process A newly process is created and is sent to the ready queue. A process was waiting and is sent to ready queue. So you are creating a ready queue for this. A process is interrupted and is sent to the ready queue. So you are maintaining a queue. So which process should be brought to ready queue is a long-term scheduler. Long-term scheduler. Whereas the short-term scheduler is from this ready queue, which processes will be taken, which process will be taken and will be sent to the running state. This is your short-term scheduler. And long-term scheduler is this, is this, is this. বলো বুঝতে পারলে কিনা? So you are maintaining a ready queue. Now, how the process will be taken from the ready queue and will be sent to the execution to the CPU is a decision of short-term scheduler. So this scheduler, short-term scheduler decision is taken in a very maybe in an order of nanosecond. It's a very fast. But long-term scheduler is little bit higher. Maybe it is a microsecond or kind of thing. So out of this waiting process, newly coming process and interrupted process, which process will be bringing and will be sent to ready state. So coming to the ready state doesn't mean that it will be immediately sent to the running state. Coming the processes or bringing the processes to running state, it doesn't mean, sorry, bringing the processes from new state, running state or waiting state to ready state doesn't mean that it will be sent immediately for execution. it will be kept in the queue. Now the short-term scheduler will decide which process will be taken from the head of the ready queue and will be sent to the CPU for execution. So that's why there is two terms. One is a short-term scheduler, another is a long-term scheduler. A new process is coming to the system. This is in the ready queue. After the IO operation, the processes are coming in the ready queue. Partially interrupted process in the ready queue. So these three are under the long-term scheduler, whereas this is short-term scheduler. Which process will be taken from the ready queue to the execution of the CPU? Okay, so these are very, so it's kind of, to some extent, is a relative matter that how much time it is taking in that or this. So normally, the processes which are taken from the new or from interrupted process or IO process, these are considered as long-term decision. But whereas for short-term decision, that means which process will be taken from the ready queue and will be executed to the CPU, that is called short-term scheduler. Okay. One important thing that you need to know is called whatever process or whatever program you have submitted for execution, either it is a CPU bound job or a IO bound job. Suppose you have written a program for printing a 10-page printout, whereas you have written a program which can compute 10 by 10 matrix, 2 10 by 10 matrix. Now, out of these two programs, can you tell me which program takes much time in the CPU and less time in the IO? And which program takes much time in IO, less time in the CPU?
So 10 by 10 matrix takes much time in the CPU and less time in the IO, and the printing one takes less time in the CPU and more time in the IO.
So the IO bound task will spend more time on IO rather than computation or the CPU. IO bound process spend more time doing IO than computation. That's why CPU burst, that means spending time in the CPU, is very small. Whereas CPU bound tasks spend more time doing on computation, less time in the, of course, IO, less time in IO. That means once you give the input as matrix input, it will take a long time for computation. So spending more time on CPU rather than IO device is called CPU bound job. And spending more time on IO, less time in CPU is called IO bound task. So any process or any program that you submit, a process is created, it is a contiguous overlapping of IO execution and CPU execution, IO execution and CPU execution. If it is an IO bound process, then it will have more time on the IO, less time on the CPU. But the reverse is just the opposite. More time on the CPU, less time on the IO. বলো আর কি আছে এখানটাতে context switch already discussed process creation so short term scheduler is invoked in a very frequently in millisecond order. Long term scheduler is invoked very infrequently, second or minute, maybe slow. So the long term scheduler controls the degree of multiprogramming. Can you define what is degree of multiprogramming? What is degree of
The number of programs, multiple programs that can be kept into the ready state or the running state, all the three states simultaneously.
That means concurrently executing program. Whether it is in a running state, waiting state, or ready state, we don't bother. We bother how many processes are executed in the system. How many processes or how many concurrent processes are getting executed in the system is called the degree of multiprogramming. So we don't bother. Listen one thing very carefully. Once you submit a program for execution, either the program is in the ready state or running state or waiting state. দেখতে পাচ্ছ তো এই স্লাইডটা? Hello.
Yes, sir.
Yes, sir. Yes, sir.
You have submitted a program for execution. A process will be created, or more than one process will be created. And those processes will be either in the ready state or running state or waiting state. Or they changes so frequently that as a human eye, you cannot detect whether it is in a ready state or running state or waiting state. As a human eye, we cannot detect whether it is a ready state or it is in the running state or it is in the waiting state. So we feel that all my processes are running by the CPU. That is called degree of multiprogramming. So whether it is in a running state or ready state or waiting state, we don't bother. We will consider all together as concurrently executing processes. In a holistically, we will consider that all my processes are concurrently executed. Whether it is in a ready state or running state or waiting state, we don't bother. We will consider that they are concurrently executed. ঠিক আছে? দেখো। Any doubt with this discussion, today's discussion?
Sir, why the time taken by long-term scheduler is a bit higher than like a short-term schedule?
No. It doesn't mean it takes higher time. The meaning is something different. The long-term scheduler is invoked. मतलब ये होता है देर में. It takes time for execution. That decision is taken after that many. Only when a new process is coming to the system or a waiting process come in the ready queue, then that decision needs to be taken. Otherwise not. So that means this is invoked. This long-term scheduler is invoked not very frequently, rather infrequently. In other way, we can say that you people used to take evening breakfast outside the campus very infrequently. Evening tiffin, not breakfast, evening tiffin infrequently. Most of the time, you used to take your evening tiffin in the campus itself. So frequency of taking the tiffin in the evening tiffin in the campus is very frequent, whereas going to the Jhoops or going to the Sidhu Kanu Stadium or city center, taking that evening tiffin, evening snacks is very infrequent. You people don't prefer to go. कभी कभी जाते हो. That is the thing. Something like that. ठीक है आया ये चरण समझ में आया?
Yes, sir. Yes.
ঠিক আছে চলো তাহলে দেখো কিছু তোমাদের বক্তব্য থাকলে বলো আমাকে anything you want to discuss. Tomorrow there will be lab. Okay. Tomorrow there will be operating system lab. Abhishek now Abhijit ki naam chhelatar? Abhishek.
Yes, sir.
Please inform everybody that tomorrow there will be operating system lab.
Sir, is there any
It will be together or it will
in the same way? In the same way. কি বলছো অভিষেক?
না স্যার মানে একসাথে হবে না আলাদা আলাদা?
একসাথে।
ওকে স্যার।
ঠিক আছে চলো দেন।
Thank you, sir.
Thank you sir. Okay, bye.
Thank you, sir.
Thank you, sir.
Thank you, bye bye.